Welcome back. Today I'm going to be going over this function increase question that usually comes up on the SAT. Once again, thanks to Anico.ai for providing this specific question in their free resources tab. But before I dive into the problem, please give this a try yourself. Okay, so here we have the function g of x, where every increase of 2/3 g of x increases by a factor of c. Right. Which choice rewrites g of x so that the value of c appears as the base of the exponential expression? Okay, so essentially in this problem, well, first of all, we have to find that what factor of c, right? The factor of c is whatever the value of g of x increases by when you increase the value of x by 2/3, right? And then you have to use that to rewrite g of x so that the value of c appears as the base. So when it says the base of the exponential expression, it's referring to the inside part of the exponential, right? That's the base. This is the exponent, of course, just to let you know, and this is just a coefficient. But we're trying to look for the base, right? So how do you even do this? Well, first, what you should right away notice, right, is that all the bases here are in terms of 2 and 3, right? You see that you're multiplying some multiple of 2 times some multiple of 3, right? So my first instinct for this problem would actually be to get everything in terms of 2 and 3, right? And it'll also be to leave the 10 by itself, right? Because if you look at all the answer choices, the 10s are left over. So how do you do that? Well, you can leave the 10 as it is. The 12, think about how do you get 12, right? Well, 12 is 2 times, sorry, it's 3 times 2 squared, right? And of course, that's to the x over 2 power. And then 18, well, that's 2 times 3 squared, right? To the x over 3. All right, so that's g of x also. But we're not quite done. We still have to kind of simplify in a way where this becomes 3 to the x over 2, right? Because remember, exponent properties, right? You multiply this exponent by the inside ones. And then, of course, this becomes 2 to the x, because 2 times x over 2 is just x. And then likewise, right, for the second base part here, I guess you could say this is 2 to the x over 3 times 3 to the 2x over 3. Okay, so I'm just going to clean things up as we go, so just so it doesn't get messy. But now we have that, right? Again, we're trying to get everything in terms of 2 and 3, right? One single 2 and 3 exponential base. So you'll notice that here you have 3 and 3, and you have a 2 and 2. If you have exponents, exponentials with the same base, you can add the exponents together, right? So you have 10, 3 to the x over 2, plus 2x over 3, right? Times 2 to the x plus x over 3. And if you simplify this, well, you get 10 times, what is x over 2 plus 2x plus 3? I always like to go off the side for these fraction adding cases. So here we have 2 times 3, just 3x over 6, and then this becomes 4x over 6, this becomes 7x over 6. So this is 3 to the 7x over 6, this is 2 to the 4x over 3, right? I can just do this in my head, right? But same logic if you can't. Just use this fraction addition, right? Look for the LCM. But essentially, when you simplify everything, right, you should get this as a g of x, right? This is kind of what we want. I'm going to remove these parentheses because now we have everything in terms of 3 and 2, right? And all the answer choices are kind of in terms of 3 and 2, so that's a good start. Okay, now our second step here is to find that factor of c, right? And you'll notice that the factor of c is only happens It only increases by a factor of c when you increase the value of x by 2/3. So what that means is, let's say you have g of 0, right? Well, we're trying to find how much it increases by when you do g of 2/3, right? Because from 0 to 2/3, right, that's a 2/3 uh, increase in the value of x. We're trying to find how much the value of g of x increases by, right? What factor it increases by. Well, g of 0, and I'm going to actually rewrite it like this. I'll explain to you why, but this is g of 2 over 3, and this is g of 0. Okay, so now when you plug this in, right, g of 0 is 10 times 3. Well, actually, if you plug in 0 here, and you plug in 0 here, you'll get 3 to the 0 times 2 to the 0. Well, that's just going to be 1 times 1, right? Because anything to the 0 is just 1. So we're left with 10 on the bottom here for g of 0. On the top, we're left with 10, 3, 7 over 6, x, which is going to be 2/3 in this case, times 2 to the 4 over 3 times x, which is 2/3. Right? These 10s cancel out. So you're left with 3, this cancels out, 7 over 9 times 2 to the 8 over 9. Right? And that's actually value of c. You might be wondering, why is that the case? Well, because, look, right, we found the factor it increases by, right? If you multiply it, and when it says factor, you're looking for that multiple that you're looking for that number that you're multiplying to get to your final value g of x. So in this case, we're multiplying this value to g of 0, right, to get to g of 2/3. Right? That's another way to interpret it. That's why I did g of 2/3 over g of 0. But this is the value of c. But once again, I want to get everything in terms of 2 and 3. Here it already is, but I want to remove as much fractions as possible. So this is 2 to the 8th times 2 to the 7 to the 1/9, right? Because you do 8 times 1/9, you get 8 over 9. 7 times 1/9, you get 7 over 9. So this is your value of c. Okay, now, which choice rewrites g of x so that the value of c appears as the base of the exponential function? Well, first of all, this is the value of c, right? 2 to the 8th times 2 to the 7 to the 1/9. You'll notice that a and b don't match that, right? The bases are different. For c and d, right, the value of c over here does match that value of c we got earlier. So you can cross out a and b, and we're left with c and d. But now we have to rewrite g of x so it shows that. How do you do that? Well, we know g of x is equal to 10 times 2 to the 4x over 3 times 3 to the 7x over 6, right? Once again, I want to remove fractions, right? So this 2 part here becomes 8x over 6, and this stays the same. You'll notice that you can kind of factor out a 1 out of 6 in the exponential. So this becomes 2 to the 8th times 3 to the 7, all to this x over 6 power. So now we have this as g of x, right? You'll notice this is really similar to our value of c here. But how do we display this value of c as our base? Well, you know that the base has to have that value of c, right? So here, g of x equals 10, 2 to the 8th. I'll use 2 parentheses here, but 2 to the 8th to the 7 to the 1/9, right? That's our value of c. We want it to display the value of c, so this part is done. But since we're rewriting g of x, we still want to keep everything the same, right? So if we're multiplying or if you're exponentiating to 1/9, well then you have to remove that exponential by exponentiating the reciprocal of 1/9, which is 9 over 1, right? So you get 9 over 1 here. The reason is, once again, if you do 1/9 times 9 over 1, those cancel out and become 1, right? And it effectively keeps the equation equal to the original function g of x. So now you're left with 9, you're left with c to this power. I'm just going to call this 9, right? Because 9 over 1 is just 9. And all of that is to the x over 6, right? Don't forget the x over 6. And once again, all of this is to the x over 6. Well, what does this simplify to? You have, I'm just going to write c here, right? Because we already have determined that c. 9 times x over 6, right? Because when you're exponentiating two times, you can multiply the exponents together. This becomes 10 c to the 3x over 2, right? Because you multiply these two. Well, what is that equal to here? This is 3x over 2. If you look at our answer choices, it's not going to be D, right? There's a 3x over 2 here, so the answer is C. So this problem is a whole lot of algebra manipulation, like uh, a lot, right? It's a lot of algebra, but there's still a layer to this that makes it easier, right? First, you have to rewrite everything in terms of 2 and 3. Sometimes looking at the answer choices helps you figure out what you need to do, right? So try to rewrite everything in terms of 2 and 3. And then after that, find the value of c, right? Because it says increases by a factor of c, you have to find the multiple of c that you're multiplying to get to that increase, right? What I mean is like uh, here, you have to figure out what you're multiplying, right? To go from g of 0 to g of 2/3, right? And then when you find that value of c out, well, now your only goal is to manipulate the original expression, right? And in a way, showcase the value of c in the exponential function while keeping everything the same. And yeah, that's really it for this problem. I hope this made sense. I know there's a lot of algebra, a lot of fast algebra involved on the SAT, right? You're trying to be as fast as possible. So if it didn't make any sense, leave any questions you had down in the comments. But thanks for watching, and I'll see you next time.